inscribed angles. Shh. Do you want me to keep that phone? Come in. Okay, inscribed angles. What type of angle was this here? And the vertex is right here. You guys know what type of angle this is? Very good. It is called a central angle. Let's say the measure of this central angle was 60 degrees. What's the measure of this arc? Now, this is called an inscribed angle. Knowing that the definition of a central angle means that its vertex is on the center, what do you think defines an inscribed angle? Huh? Anybody? Why do you think, how do you think I can say that, why do you think I can say this is an inscribed angle? What do you think makes an inscribed angle? Vertex is on the circle. Key point, the measure of an inscribed angle will always be half its intercepted arc. So what is the measure of that angle going to be? The measure of an inscribed angle will always be half its intercepted arc. What is the measure of the arc it intercepts? 60. So what's the measure of that angle? It's 1/2 of 60, which is what? 30 degrees. Okay. Another thing about inscribed angles. Let's call this angle 1. Let's call this angle 2. What do you think I can say about those two angles? Stop writing and just look up here. What do you think I can say about those two angles? Up here we said that what? An angle, the measure of an inscribed angle is always what? Half the measure of its intercepted arc, correct? So if you look down here, what arc does angle 1 intercept? Can anybody tell me? Arc A to what? A to B, correct? What arc does angle 2 intercept? Huh? Excuse me? A to B. So if they're the half of the same thing, what do you think I can say about angle 1? Is what? Doesn't angle 1 have to be congruent to angle 2? Because then since they have to, both of them have to be half of AB, aren't they the same thing? Agreed? So anytime you have two inscribed angles intercepting the same arc, then they have to be what? Congruent. What if I told you the measure of this one was, say I said the measure of angle 2 was 25 degrees. What's the measure of angle 1? What's the measure of arc AB? Huh? It has to be 50, doesn't it? What's the measure of this central angle then right here? What's the measure of that angle? Huh? 50 degrees. So it all works together? Okay, quick make another circle. Here's the center of that circle, let's say. What do we call this line right here? You don't have to draw this, just watch. What do we call that line? That is a diameter. Can you guys tell me right now what the measure of this angle right here is? Nope. What's the measure of this angle right here? Let's go back to here. Read this out loud. Here we go. The measure of what? Will always be. Oh, let's start over again. Ready? 1, 2, 3, go. Always be half its intercepted arc. What is its intercepted arc from here to here? Can anybody tell me? What is the intercepted arc here? Here to there. Can you guys tell me the measure of that intercepted arc? Huh? 180 degrees, is it not? That's the arc it intercepts. And what do we say here? The measure of an inscribed angle will always be what? Half its intercepted arc. So what does that make this one? Huh? Talk louder. Very good. This is a theorem, but does it really need to be? What do you know that each semicircle's arc's always going to be? If this is a diameter, it's always going to be what? Well, if it intercepts that arc, then it's got to be half of 180. It's got to be what? 90. Don't have to write this down either, but another one they say, a lot of these are all based on that one fact, that an inscribed angle is half its intercepted arc. A lot of these theorems, they're stuff that's just derived from that. They have a theorem that talks about this. Well, I want you to look at angle D and angle B. What's the intercepted arc of angle B? From what? What do you think, Farad? What's the intercepted arc of angle B? What does it intersect? Intercept, what arc?
You want me to tell the truth?
Yes.
I don't know.
Okay. What do you think? Intercept means that it's the arc that it runs into. So if you trace angle B, what is the arc it's holding if these are its arms? From what? Okay, I'm talking about this angle right here. What is it holding? Arc from what to what? From A to what? Does everybody see that? Isn't that what angle B is holding? If this is its hands here and here, it's holding here to here, is it not? Does everyone agree? What is the arc that angle D is holding now? Anthony, what do you think? Angle D is holding what? Arc from what? A to C, the other side. Together, what do they make? The whole what? Circle, right? Together, the arcs they're holding make how many degrees? So what do you think these two added together have to be? Huh? 180 degrees. Because they're always half what? Measure of the arc they inscribe, correct? So what do you think these two are going to add to? What? 180 degrees. Because the arcs they're holding end up being what? The whole circle. Okay? Does that make sense? And that's the other theorem from this section. Now, everybody get those worksheets out. Okay, it says state if each is an inscribed angle. Is this an inscribed angle? Do we really not know what makes something an inscribed angle? Seriously? On film, I'm about to make all of you get up and do jumping jacks. Nobody in here understands that an inscribed angle, the vertex where it changes direction, is on the circle, right? Is that hard? Or are you guys just not listening? You just had 2 days off. You ought to have plenty of rest. Where's the vertex of this circle? Is it on the circle? So is it an inscribed angle? Yes. Use the big boy voice, please. Now, we're supposed to name, if it is, name its intercepted arc. What arc is it holding? R to what? So we're supposed to name that. So RS. I want you to go ahead and trace over it so I see you realize that's the intercepted arc. R to S. I guess actually, what should I say here? Does that look like the major arc? So I should probably say R what? XS. Think you guys can do that? No? Now, on these, they say find each the measure of the arc of the angle indicated. They want to know this angle. What is the measure if it's inscribed? So I know it's what? What is it of the arc it intercepts? Half. What is the arc it intercepts? Tell me, from what to what? And then to where? And then to where? Trace that over there. There's not a whole lot of work for you to do here, so you can at least do that for me. So, and then you can say it's half of what? How many degrees? So what does it make it? There's your answer, and circle it. On a lot of these, you've just got to look past all the stuff they're putting in to try to confuse you. Is this an inscribed angle, the one they want to know? Yes, no, maybe, I don't know. Is it? Yes, it is. What is the arc it's holding from what to what? A little short one here from C to N. Do we know its measure? So what do we have to do? Divide that by? And what do we get? So what's the measure of our angle? Circle it. Can you guys handle that? Now, here's where you're going to run into the ones like number 16. They want you to solve for x. So you've got to relate this to this. You can look at it two ways. You can look at the measure of this arc, that this is what? Half of it? Agreed? Or you can look at it the other way around, that if you double the inscribed angle, you'll get what? The arc it intercepts. Isn't this the arc it intercepts? What do you guys want to do? How could I create an equation here? 35 times 2 would equal whatever the arc it intercepts is, which is? So you'd get 70 is equal to what? What's x equal to? Here you're going to have to just try to figure out everything you know. These don't relate to each other directly, do they? The two things I know numbers for. So everyone watch up here. What do you know that 31 tells you? What does that tell you that this angle's 31? Denny, what do you think? If this angle's 31, what does it lead me to that I can know about something else? The arc is 62. So the arc from here to here is 62, right? Okay. Does that help me? Possibly. I know the arc from here to here is what? 13x minus plus 1. Do I know any way to relate all this information? Is there anything else significant here? Crop, what do you think? Do you see anything else significant that would help me somehow relate the numbers I know about this arc with this right here? I need to find a way to say this is equal to this, or this plus this is equal to this, something to that effect. One thing to always remember is, what arc do you always know the measure of? If it's a what? If it's a diameter, I know the arc it contains has got to be what? 180, right? What is this arc from here to here got to be then? I know what the two pieces are, right? So what is my equation here? I've almost kind of written it up here, haven't I? Here to here and here to here has to equal what? So what would my equation be? 13, louder, 13x plus what? 62 would all have to equal what? You have some like terms to add? What am I going to do now? Nine, right? 9 times 10 is 90. 9 times 3 is 27. 27 plus 90 is 117. Guys, the plan has still stayed the same. I may just shorten the assignments for, or give worksheets for 10.5 and 10.6. We will still test on it on Friday. What has changed is when all of the assignments are due. I will probably make, I may just have all of you turn them in on Thursday next week, so I have a day to get them graded. First of the hour on Thursday. So that way it gives you a work day on Monday and Tuesday stuff, and I won't make it long. And that kind of stuff. However, though, I would like you, if you get stuff graded and corrected, I'd like you to turn it in so I can start grading some of it before spring break gets here, so I can get as much graded before. Okay? Let's get to work on this. Show all steps and work, as always. Prove to me you're doing the work, just like I said.